Your boss asks you to extract data from Amazon S3, transform it using Python, and load it into a Fabric data warehouse. Which ingestion method should you choose? If you hesitated for even a second, this video is exactly what you need. Welcome to part 2 of our DP600 training series, where we're tackling the most exam-critical section, data ingestion and preparation. Today, I'm showing you how to choose between data flows, pipelines, notebooks, and shortcuts based on real scenarios you'll face both in the exam and at work. Let's make sure you never pick the wrong tool again. The data flows path, a no-code adventure. What if you could ingest data without writing a single line of code? That's exactly what data flows in Microsoft Fabric are designed to help you do, whether you're connecting to cloud-based applications, transforming raw local files, or combining multiple datasets into one streamlined process. Data flows take care of it all. No coding experience needed. Think of them as a low-code or no-code tool that lowers the barrier to working with data. At the heart of data flows is Power Query, a powerful engine that many of you may already know from tools like Excel and Power BI. Here, it works as an intuitive interface for extracting and transforming data, so you can clean, shape, and prepare it directly within Fabric. Let's say you need to pull data from your organization's on-premises database. Using the on-premise data gateway, you can bridge this gap, loading the data securely into Fabric without writing a single script. It's drag-and-drop simplicity with serious back-end functionality. But as easy and accessible as data flows are, they aren't without their challenges. They're a great fit for small or moderately sized datasets. But when you start working with millions or billions of rows, their performance can struggle. For example, processing massive tables from a data warehouse or connecting to a cloud service with a high query load can lead to slow execution times. And then there's the matter of parameter passing. Data flows don't have a built-in way to dynamically adjust parameters like dates or customer regions for metadata-driven workflows. Although you can create workarounds within Power Query itself, the absence of this feature can complicate scenarios where flexibility is critical. Let me give you a tangible example. Imagine a sales team wants to connect their external customer relationship management (CRM) system to generate a weekly report. Their CRM stores information like customer contacts, sales leads, and activity logs, all of which need to be cleaned and merged before analysis. In a typical data flow scenario, you would select the appropriate Power Query connectors to bring in this data. With access to over 150 connectors, including popular platforms like Salesforce, Dynamics 365, and Google Analytics, the setup process is straightforward. Once the data is loaded, you can use data flow transformations to merge tables, filter the rows you need, and create calculated columns for aggregated sales metrics. Everything happens right in Power Query's visual interface without you having to worry about syntax or coding. However, as useful as this sounds, imagine that this CRM contains hundreds of millions of records spread across multiple entities. The sheer size of the data can present a problem for data flows. Validation rules, such as checking for duplicate records or missing required fields, can add even more processing time. That's where Microsoft's fast copy feature comes in. This feature shares the same robust infrastructure as the data pipeline's copy activity, which boosts the performance of data ingestion tasks. By enabling fast copy, you can significantly reduce the time it takes to load large datasets into Fabric, making data flows a more viable option for situations where speed is critical. Still, even with improvements like fast copy, there's a limit to what data flows can handle. If you start running into lag, failed operations, or challenges coordinating parameterized workflows, data flows alone may not cut it. This is especially true if you're juggling highly complex scenarios like integrating multiple systems or processing data that requires real-time validation checks before ingestion. For scenarios requiring such scale or customization, it's time to look beyond the simplicity of no-code tools. Another challenge worth addressing is data validation. Let's revisit the CRM scenario from earlier. Say you need to ensure that no duplicate customer records are loaded or that all sales transactions have a valid date and amount. Data flows can handle these checks within Power Query routines to some extent, but embedding complex validation logic isn't their strong suit. For users working at scale or with intricate business rules, this limitation can create friction. Errors may pop up downstream if the validation step misses any issues, and fixing this retrospectively can be costly in both time and effort. Data flows also allow you to upload local files such as CSVs directly into Microsoft Fabric. For example, if you're working on a one-off task, like consolidating marketing campaign results from spreadsheets, you can load them straight into a data flow and transform them on the fly. This feature is useful for tasks where speed and ease take precedence over automation or scalability. But again, once you start to incorporate more dynamic external data or highly transactional systems, these static file uploads become less practical. Looking at the bigger picture, data flows are invaluable for quick wins and smaller scale projects. You can use them to clean datasets, enrich them with calculated fields, and load them into Fabric, all without worrying about manually writing queries or creating robust orchestration logic. However, they start to lose their appeal when tasks grow complex. Use cases like combining massive datasets, orchestrating processes that span multiple services, or implementing flexible and reusable metadata-driven logic are better served by tools designed to handle that level of intricacy. And this leads us to an important question. How do data flows stack up against other options Microsoft Fabric offers? If you've ever hit the limits of what data flows can achieve, you've probably wondered whether moving to pipelines or notebooks is the right step. Both claim to bring something extra to the table, with pipelines offering scalability in orchestration and notebooks providing fine-grained control for transformations. The reality is each tool has its strengths, and in the next section we'll explore what happens when the size and complexity of your data demands a framework bigger than a data flow. Specifically, we'll pivot to pipelines, the orchestration powerhouse that can handle what data flows can't. Data pipelines, the orchestration powerhouse. Imagine orchestrating multiple data processes seamlessly while handling massive complex data sets. Sounds ideal, doesn't it? In Microsoft Fabric, data pipelines are designed exactly for this purpose. They act as the backbone of data orchestration, giving you the tools to automate and manage intricate workflows without constantly needing manual intervention. When you're working with vast sources of information across different systems and need everything to fall into place efficiently, pipelines are your go-to solution. At their core, data pipelines are built for scalability. Whether you're processing thousands of rows flowing in from Azure Blob Storage or orchestrating data movement between multiple databases, pipelines allow you to chunk and automate these processes while maintaining control. To picture this in action, let's explore a typical real-world scenario. Suppose your team needs to ingest data from several Azure SQL databases while ensuring proper failure handling for any issues during the process. Using a pipeline, you can create a workflow that loops through each database, extracts the required tables, and merges the data into one centralized destination. If any step fails, maybe one of the tables isn't reachable, the pipeline can automatically trigger a retry attempt or even log the error and notify you of what went wrong. This kind of flexibility comes from the control flow logic pipelines offer. With features like looping, conditional branching, and failure paths, you can fine-tune workflows to handle even the messiest scenarios. Let's say, for example, you're integrating data from 5 source systems, each with its own update schedule. Some data might arrive hourly, while others are updated weekly. Pipelines allow you to configure actions based on these differences, automating ingestion based on the presence of the new data, skipping unnecessary steps, and even notifying stakeholders when updates are completed. But what truly sets pipelines apart is their metadata-driven structure. Not only can you automate repetitive tasks, but you can also parameterize pipelines to make them dynamic and reusable across projects. Imagine needing to process 50 sets of similar tables across different customers within the same source schema. Instead of creating hard-coded workflows for each one, you can design a pipeline to accept parameters, customer ID, table name, or storage paths, and run dynamically for all datasets without building duplicate pipelines. This design saves time and reduces the chances of errors from repetitive setup. That said, pipelines have limits. For all their orchestration power, they aren't built for direct data transformations or uploading standalone files from a local system. For instance, if your ingestion process requires heavy cleaning or reshaping of data before it's usable, you'll need to add complementary tools. A notebook or data flow can be embedded within the pipeline to handle those transformations, but the pipeline itself doesn't natively perform those actions. This lack of built-in transformation capabilities means pipelines are perfect for directing the flow of data but rely on other tools for more intensive ETL tasks like calculating new metrics or removing redundancies. Scheduling is another area where pipelines really shine. They provide far more flexibility compared to scheduling data flows alone. For example, you can schedule a pipeline to run every 15 minutes, trigger retrace on failure, or add notifications directly through email or Teams for monitoring. In situations where the pipeline integrates data transformation or validation steps like running a notebook or refreshing a data flow, these activities can be timed down to the second for precise orchestration. For example, say a financial report depends on data that's refreshed from multiple systems by 8 a.m. sharp daily. With pipelines, you can automate the entire process, including monitoring steps, so you'll know if the report is ready on time or hear about it immediately if it isn't. Now let's return to our earlier Azure ingestion example. You've pulled data successfully, but what happens if something changes in the middle of the process? Maybe a source schema is updated, breaking the workflow, or a new table is added unexpectedly. Pipelines can incorporate logic to evaluate metadata at runtime. You could, for example, configure a pipeline to first check the source for schema changes before proceeding and stop execution if changes are detected that might corrupt the ETL process. This metadata-driven ingestion ensures you don't just blindly execute processes but operate with checks and balances in place. Despite their strengths, pipelines do come with a few current limitations. One key restriction is their limited cross-workspace support. For now, pipelines require both your data source and destination to reside within the same Microsoft Fabric workspace. If you're working in environments with data distributed across multiple workspaces, this constraint can feel limiting, particularly for projects requiring integration across departments or business units. The good news is Microsoft has publicly acknowledged this limitation and is actively working on solutions. Advancements in cross-workspace functionality could open up even greater flexibility for pipelines in future updates. Another example of pipeline's orchestration ability involves executing mixed workloads. Let's say you're working on an ingestion pipeline for an e-commerce company. The pipeline is tasked with several coordinated activities: loading product data from a SQL database, running a Python-based transformation notebook to validate and clean customer order records, and using a stored procedure to insert those cleaned records into a central sales data warehouse. Pipelines aren't just orchestrating these tasks, they're controlling dependencies, preventing redundant execution, and ensuring each activity has time to complete properly before the next step. Of course, even the best orchestration cannot replace the need for robust data transformation. At some point, you'll hit a wall with what pipelines can automate, particularly when processing highly complex or unstructured datasets. The question then becomes, what do you use to actually extract, validate, and prepare that data before it flows through the pipeline? This is where notebooks come into the picture. Think of them as the flexible coding counterpart to pipelines structure, a tool equipped to handle the nitty-gritty of transformations. While pipelines might check that a notebook runs successfully as part of a broader workflow, the notebook itself is the one writing reusable Python scripts or running validations against data from APIs. Finally, it's worth noting just how central pipelines are to building hybrid workflows in Fabric. They seamlessly integrate with other tools, triggering data flows to process smaller jobs, leveraging shortcuts for real-time access to external data, or combining these elements into a single cohesive pipeline. You could even map out end-to-end workflows that range from ingesting CSVs to dynamically generating real-time Power BI reports in response to updates. But alongside these strengths lies their reliance on complementary tools for performing the actual data processing once it's orchestrated. So pipelines prove themselves to be powerful orchestrators for large-scale workflows, especially in scenarios with sprawling datasets and intricate dependencies. They handle scheduling with precision, optimize data integration tasks, and offer highly reusable logic through parameterization and control flows. But when it's time to transform data, pipelines alone aren't enough. They're the framework where other processes like notebooks or data flows do the heavy lifting. And that brings us to our next topic. When transformations become the centerpiece of your workflow, How do you handle them? The flexibility of notebooks, where Python unleashes the full potential of data analytics, might just be the answer. Unleashing notebooks, the coder's playground. What if you could harness the power of Python to extract, validate, and transform data with precision? Microsoft Fabric's notebooks make it possible by offering the flexibility of custom coding for even the most complex data workflows. Whether it's tackling API-based data extractions, creating reusable logic for repetitive processes, or handling intricate validation rules, notebooks stand out as the coder's playground for advanced transformations. Notebooks in Fabric are designed with versatility in mind, and one of their key strengths lies in their ability to manage data ingestion through APIs. APIs often require more than just a simple connection. They need logic to handle authentication, extract specific data fields, manage pagination for large datasets, and deal with errors like rate limits. For example, let's say you're extracting sales data from an API provided by an external vendor. This API uses OAuth for authentication, returns transaction data in paginated chunks, and requires a custom header for every request. Using a notebook and its support for Python, you can write code to handle all of this seamlessly. You could integrate libraries such as requests to navigate the authentication process, extract the necessary data while following pagination links, and ensure that failed requests are retried automatically. By the time the notebook finishes running, you'd have a fully structured dataset ready for the next steps in your workflow. Now, a key feature that notebooks bring to the table is their support for reusable parameterized code. This is particularly beneficial when you're working with similar tasks across multiple datasets or projects. Imagine your sales data example applies to different regions, North America, Europe, and Asia, each needing a slightly adjusted query. Instead of rewriting your API extraction for each region, you can define parameters to pass in the region name and dynamically adjust the API calls and data transformations within the notebook. This saves significant time and ensures consistency whenever changes are required. Additionally, you can save these notebooks, reapply them to future projects, and build a library of robust, tested solutions over time. For all their flexibility, notebooks do come with a learning curve, particularly for users who aren't already familiar with scripting languages like Python or Scala. Diving into code to manage ingestion workflows might feel intimidating at first, especially if you're transitioning from the graphical user interface tools like data flows or pipelines. Even tasks like implementing API authentication require foundational knowledge of methods and libraries. However, for those willing to acquire the basics, the trade-off is immense control over the way data is handled. And it's not just about transformations. Almost every element of a notebook can be customized for the specific needs of the workflow. Once the data has been extracted, notebooks shine during the transformation and validation process. Let's extend the same API scenario. After pulling the sales transaction data, you need to ensure every record meets quality standards before ingestion. You can write logic to validate transaction dates, ensure amounts are within expected ranges, and even cross-verify customer IDs to catch potential mismatches. The notebook can flag invalid rows, lock them for review, and proceed to process only the clean, validated data. This ensures that issues are caught and corrected early in the pipeline, reducing downstream errors and rework. That said, notebooks have their limitations, especially when it comes to direct data movement within Fabric. One significant drawback is that notebooks cannot directly write data into a Fabric data warehouse. If your workflow needs to move the validated transaction data into a centralized warehouse for reporting or aggregation purposes, you will need to integrate additional tools. A pipeline, for example, could orchestrate the notebook's execution and then take the validated output from the notebook's processing to load it into the warehouse. This reliance on complementary tools means you cannot rely solely on notebooks for end-to-end workflows, but instead must think of them as a powerful piece of the larger ingestion picture. Despite this, notebooks perform efficiently in terms of resource usage and capacity. Compared to other methods like data flows, notebooks often demonstrate superior performance, especially for workloads that require heavy transformations. The Spark infrastructure they run on ensures that they scale well with data size. For instance, instead of choking on tens of millions of records, a notebook can process them efficiently, leveraging distributed computing and parallelization. This can be a cost-effective option when you're trying to optimize your Fabric capacity units over time. However, the trade-off is that Spark session startups can occasionally introduce delays for small workloads. If your task involves handling just a handful of records, notebooks might feel overpowered for the job. Let's go back to another practical example of integrating reusable logic into your workflows. Imagine your team works with an e-commerce data set that includes orders, customer reviews, and inventory statuses, 3 separate sources that need to be reconciled for reporting. Instead of writing transformations for these 3 sources separately, you can design modular, reusable functions within a notebook. For instance, you could create a validation function for ensuring non-empty product IDs or an outlier detection function that identifies abnormally large order volumes. Each function can be reused across the 3 datasets without duplication of work. This type of efficiency becomes invaluable for large-scale projects, where consistency and maintenance are as important as functionality. Of course, when you're extracting and working with external systems, failures do happen, whether it's network issues, API rate limits, or server outages on the source end. A notebook used in a Fabric pipeline can be configured with retry mechanisms to minimize these failures. For example, in your pipeline, you could set the notebook activity to retry up to 3 times in case the first attempt encounters a transient issue, like an API rate limit exceeded error. This ensures your workflow remains reliable even when external factors fall out of your control. However, if errors persist, you'll need to implement logging and alerting to identify and follow up on the root causes quickly. Notebooks also make capacity usage transparent, allowing you to optimize performance as your dataset scales. Let's revisit the sales transaction API workflow. Suppose it initially returns only 1,000 records per request. A year later, as your sales grow, the API begins returning 10,000 or even 100,000 records. Notebooks allow fine-tuning of the extraction process, for example, modifying pagination loop settings or enabling parallel processing of data batches to maintain consistent performance without exhausting capacity units. This capacity awareness is critical for long-term workflows that scale with the growth of your business. Despite the advantages, it's important to think about how notebooks integrate into larger workflows. On their own, notebooks excel at precise transformations and extractions, but they don't handle orchestration efficiently. Imagine needing to run a notebook task every hour, check its status, and move the processed data into downstream systems. That kind of automation would require a pipeline to keep everything in sync and ensure each step triggers correctly. In other words, notebooks are an amazing tool for advanced code-heavy tasks, but find their full potential when combined with orchestration tools. While we're on the topic of integration, one frustration you might encounter is the lack of direct connectivity from notebooks to certain systems. For real-time access to external data or providing live links without any data movement, notebooks aren't the solution. In workflows where immediate live connections are a priority, you may find yourself needing a different tool altogether. And that brings us to shortcuts, another key feature of Microsoft Fabric. These are specifically designed for real-time external data access, making them the exact opposite of notebooks' batch-oriented workflow. While a notebook might take extracted API data and transform it over 10 minutes, a shortcut would link directly to external storage, allowing users to query the data in real time. Shortcuts solve the challenge of providing instant access without physically moving large data sets, bridging a gap that notebooks don't typically cover. So, where do notebooks excel and where do they fall short? Simply put, notebooks are unparalleled for handling advanced data transformations when code precision is critical. They allow for deep customization, offer reusable structure through parameterized code, and perform efficiently even with large datasets or complex API integrations. However, they don't operate as all-in-one solutions. You'll need orchestration to chain notebook tasks into robust workflows, and you'll need other tools like shortcuts or pipelines for tasks they aren't designed to handle, such as real-time data access or direct warehouse writing. That's why the key takeaway isn't to choose notebooks over other tools. It's to recognize when their unique strengths are the best fit for a task and where they require support. Next, we'll explore shortcuts and how they address an entirely different challenge: accessing external data in real time without the wait. Shortcuts. Real-time data access made simple. What if you could access external data in real time without the need to move it into Microsoft Fabric? That's where shortcuts come into play. They serve as a live link to your data, allowing you to work with it as though it were already inside Fabric without actually copying it over. This capability is a game changer when you're dealing with external storage solutions like Amazon S3 or Azure Data Lake Storage Gen 2, where moving data physically might not make sense because of cost, time, or technical constraints. Instead of waiting for data to be ingested or worrying about syncing updates, shortcuts allow you to work with the latest information instantly. Let's think about a scenario. Suppose your organization relies on an Amazon S3 bucket to store raw analytics data for sensitive telemetry. Every minute, new data logs are added to this bucket. Your task requires real-time access to analyze this data for up-to-the-minute trends. Trying to copy this information into Fabric every few minutes would be inefficient, not to mention potentially expensive if the dataset is large. By setting up a shortcut to the S3 bucket, you can link directly to it and access the logs as they are updated, all while keeping the original data in its external location. This type of real-time access is particularly important for use cases like live dashboards or business-critical reporting. For example, imagine building a dashboard for sales trends that needs to show live updates as orders come in. Shortcuts eliminate the lag caused by data ingestion workflows, making sure that the numbers on your dashboard match what's happening in real time. You don't have to wait for a pipeline to refresh or schedule a batch job. The data is available immediately, saving you both time and unnecessary complexity. That said, shortcuts come with their own set of challenges, particularly around permissions management. To set up a shortcut, you need the right level of access in both the source system and the Fabric workspace. For instance, you'll need write permissions in your Fabric workspace and read permissions for the external storage location you're linking to. If you're planning to sync files or even entire folders, ensuring consistent permissions across all users and systems is crucial. Additionally, when writing new data back to the linked location through the shortcut, you'll need both read and write permissions in the shortcut's original target and the workspace. These layers of permissions are essential for ensuring data security and integrity, but they also mean you need to pay careful attention to access configurations before pulling everything together. Now let's walk through what setting up a shortcut to an Amazon S3 bucket might look like in practice. When creating a shortcut, you first need to connect Fabric to your AWS account. This process involves generating credentials, typically an access key and a secret key from your S3 configuration. These credentials allow Fabric to authenticate with Amazon S3 securely. Once connected, you can define which bucket or folder you want to link as a shortcut. If the bucket contains subfolders, shortcuts can also include all of these files automatically, simplifying the integration. Once the shortcut is established, the files in the Amazon S3 bucket will appear in Fabric as if they were local tables or datasets. But remember, no data has been moved. It's all accessed directly from Amazon S3. There's another angle to consider when implementing shortcuts: cross-region egress fees. If your Fabric capacity is located in one Azure region and your external storage, such as the S3 bucket, is located in another geographic data center, you'll be charged for the data transfer between those regions. For example, say your Fabric environment resides in UK South, but your S3 bucket is hosted in the West US region. Each gigabyte of data accessed across this region gap incurs a cost, typically around 1 cent per gigabyte in Azure. For small data sets, this cost might seem trivial, but when you're operating at scale, working with terabytes or even petabytes of data, the fees can quickly add up. It's a reminder that while shortcuts save you time, they don't eliminate every logistical consideration. It's always worth assessing whether the financial impact of cross-region access outweighs the convenience benefits in each case. Shortcuts aren't only about individuals setting up manual connections. For organizations working with hundreds or thousands of datasets, Fabric's REST API comes into play. The REST API allows you to programmatically create and manage shortcuts, offering an efficient way to automate processes that would be tedious and time-consuming if done manually. For instance, let's say you manage multiple folders, each representing a category of data: sales logs, inventory reports, customer feedback, and so on. Instead of setting up each shortcut individually through the UI, you can use the API to handle the configuration in bulk. Whether you're linking to an Azure Data Lake storage folder or an S3 directory, the API makes shortcut management scalable and repeatable. This programmatic capability is especially useful for large teams or enterprises. If your organization often adds or removes datasets from external sources, automating shortcut creation can ensure your Fabric environment stays synchronized without relying on manual updates. For example, as new project folders are added to your external data lake, the API can automatically establish shortcuts pointing to these folders, ensuring that project managers and analysts always have immediate access to the latest data. Now, let's think about scenarios where shortcuts truly shine. One obvious example is real-time reporting. Financial teams, for instance, often rely on up-to-the-second accuracy for dashboards reflecting cash flow, stock movements, or expenses. Any delay in ingesting these datasets could lead to outdated insights, potentially risking crucial decisions. By leveraging shortcuts, these teams can access financial records or live transaction logs directly from their external storage systems without waiting on a full ingestion or transformation process to complete. Another scenario involves handling massive, unstructured datasets. Suppose an organization processes raw log files generated by IoT devices, with these logs stored as JSON files in a Google Cloud storage bucket. Instead of ingesting terabytes of raw data and then processing it in Fabric, the team can create a shortcut to the folder containing these files and process it only as needed. In a way, shortcuts act as a bridge, offering live access without requiring the space, time, or resources to duplicate the data into Fabric. But of course, shortcuts don't operate in isolation. Combining them with other tools inside Fabric is often necessary for broader workflows. Imagine you've set up a shortcut to an S3 bucket for real-time access, but now you also need to transform that data or orchestrate it into new workflows. This is where pipelines play a complementary role. A pipeline could, for example, trigger a notebook to run transformations on data accessed through a shortcut, or execute a series of tasks that take shortcut-linked data and move it into structured tables for long-term storage. Pipelines bring orchestration and repeatability into the mix, ensuring that shortcuts are used as part of a coordinated framework rather than one-off solutions. The connection between shortcuts and other tools doesn't stop there. Power BI templates, for instance, can be linked to shortcut-enabled datasets to present visual reports in near real time. Imagine a retail manager monitoring performance metrics across hundreds of stores each day. If these metrics rely on shortcuts to retrieve live sales data, the Power BI dashboard will always reflect the freshest numbers, giving decision-makers instant access to actionable insights. Shortcuts are particularly valuable for teams working collaboratively across departments or locations, as they provide shared access to datasets without the delays of transferring and uploading files for every user. However, this shared access requires careful permissions management to ensure data security. Permissions ensure that only intended users can access or modify the data linked by shortcuts, and they are a necessary safeguard when external datasets contain confidential or regulated information. In the end, shortcuts in Microsoft Fabric solve the challenge of accessing external data efficiently and in real time. They're perfect for use cases where immediate access is critical and moving data is either impractical or unnecessary. Whether you're working with Amazon S3, Azure Data Lake Storage Gen 2, or any other supported system, shortcuts let you eliminate the manual headache of syncing data into Fabric while keeping your workflows as agile as possible. But shortcuts are just one piece of the broader picture. Real-time data access is powerful, but more often than not, it needs to be integrated with other tools to deliver complete solutions. That's why the next step in our journey is exploring how combining tools, shortcuts, pipelines, notebooks, and more can create workflows that are not just efficient, but also robust and scalable. The power of combining tools, a best practice approach. What if the best solution wasn't choosing just one tool, but combining the strengths of several? In Microsoft Fabric, each tool serves a specific purpose, but the most efficient workflows often come from layering them together in ways that maximize their individual benefits. Instead of thinking about pipelines, notebooks, shortcuts, or stored procedures as standalone solutions, imagine them as pieces of a puzzle that, when connected, form a complete and highly optimized data ingestion and orchestration framework. At first glance, combining tools can feel complicated. You're not just managing a single notebook or a shortcut. Instead, you're linking processes across various systems, ensuring they work seamlessly to deliver accurate and timely results. A straightforward pipeline becomes dynamic when paired with parameterized, stored procedures or reusable logic coded in a notebook. Add in the real-time access of shortcuts, and now you're dealing with a layered workflow that balances flexibility, performance, and simplicity. But managing all those connections, dependencies, and potential points of failure requires careful planning and understanding. Let's start with a real-world example to demonstrate how these tools complement one another. Picture a scenario where your organization needs to aggregate sales data coming from two very different sources. The first source is an external REST API that updates daily with regional sales metrics. The second source is a live Azure Data Lake folder with raw transactional data that changes minute by minute. Combining these datasets into a unified warehouse for analysis involves several steps. First, you'd use a notebook to handle the API connection. Using Python, the notebook can authenticate requests, navigate pagination, and extract only the relevant sales fields. Once the notebook completes its processing, the data could then move into a pipeline where orchestration logic ensures everything runs in sync. The pipeline schedules the notebook's API extraction process, ensures retries occur for transient failures, and coordinates the next steps for integrating the live Azure Data Lake data. Now, this is where shortcuts come into play. Rather than copying the entire transactional data folder into Fabric, you could create a shortcut to link directly to the external Azure Data Lake storage. This shortcut provides a live connection so your pipeline can pull the freshest transaction records without duplicating data. With both datasets, the API feed processed by the notebook and the transactional data linked via the shortcut, flowing into the pipeline, the system is ready for transformation. And for those transformations, stored procedures step in as the next layer. Stored procedures bring the power of a database engine to these workflows, offering precise, secure, and consistent transformations. In this scenario, a stored procedure embedded in the pipeline could take the cleaned API output and the live transactional data, join the two data sets, and apply business logic like calculating regional totals or filtering out erroneous records. Using stored procedures for this step ensures consistent processing each time the pipeline runs, and it encapsulates your business rules into a reusable database-driven structure. Once the data has been fully combined and transformed, it can be loaded into a warehouse for reporting. This is where the final piece, a Power BI template, comes into the picture. Power BI template files, or PBITs, allow you to create structured, predefined report formats that adhere to standardized visualization rules. By using PBITs, the organization ensures that every report built off this combined data is not only visually consistent, but also reliable in terms of its underlying analytics. These templates can include predefined visuals, data connections, and even calculated fields, so users across departments don't have to rebuild everything from scratch. For instance, sales managers could easily pull up dashboards showing total revenue, regional trends, and live transaction metrics, knowing that every report adheres to the company's approved standards. Let's take a closer look at the challenges involved in combining these tools. The first hurdle is ensuring all components integrate smoothly. For example, when a notebook processes API data, it must output the data in a format compatible with the next step in the pipeline. If the notebook produces a dataset with too many nulls or mismatched fields, the stored procedure downstream in the pipeline might fail. Similarly, shortcuts depend on maintaining consistent access permissions. If permissions aren't properly configured for the Azure Data Lake folder linked through a shortcut, the pipeline might lose access mid-process, creating bottlenecks. Another complexity lies in managing the dependencies between tools. In workflows like this, certain steps depend on others completing successfully. Imagine the notebook's API extraction fails due to an authentication issue. If the pipeline doesn't detect and correct this, the downstream stored procedure would attempt to process incomplete data, leading to errors. To handle these situations, Pipelines offer robust control flow options, including conditional branching retries and error handling routines. For instance, the pipeline could retry the notebook 3 times before sending an alert to the data engineer if the issue persists. This adds a layer of reliability to workflows, ensuring smaller failures don't disrupt the entire system. Integrating stored procedures adds another layer of benefits. For example, stored procedures allow for parameterized input, making transformations dynamic and reusable. A stored procedure could accept parameters for fiscal year and sales region, enabling it to process regional data for different timeframes without requiring any code changes. This reusable design is particularly important when scaling workflows or adapting them to new business requirements. Additionally, stored procedures encapsulate logic, meaning the transformations occur securely within the data warehouse environment, reducing the risk of exposing sensitive information during processing. For instance, if you're dealing with sales records that include customer PII, the stored procedure can restrict access to sensitive fields while still delivering aggregated insights downstream. Despite these advantages, you're still left with the question, how do you keep track of such a complex workflow? This is where the Lineage View in Fabric becomes an indispensable tool. With Lineage View, you can visualize the relationships between each component in the workflow, how data flows from the API through the notebook, into the pipeline, and then through stored procedures before landing in the warehouse. This bird's eye view is particularly useful for identifying dependency issues. Say you're planning to modify a shortcut's location to link to a different Azure folder. The Lineage View would show you every downstream dataset, report, or process relying on that shortcut, so you can update these dependencies proactively and avoid breaking the workflow. Another important consideration is how each tool addresses different operational priorities. Shortcuts prioritize speed and real-time access, but rely on pipelines for orchestration and stored procedures for deeper data transformations. Pipelines, on the other hand, excel at scheduling and automation, but they rely on tools like notebooks or stored procedures to handle specific tasks, such as extracting data or performing complex calculations. Understanding these strengths and designing workflows that enhance them creates a best practice approach that delivers both flexibility and reliability. Finally, incorporating Power BI templates promotes consistency across the reporting layer, while the operational tools, pipelines, shortcuts, notebooks, and stored procedures build the foundation for seamless data processing. PBITs ensure the data is conveyed effectively. By predefining layouts, metrics, and color schemes, templates reduce the risk of errors during report creation, allowing end users to focus on decision-making rather than troubleshooting formatting issues. The takeaway here is simple. No single tool will handle every part of your workflow perfectly. Notebooks are perfect for transforming data through custom logic but need orchestration from pipelines. Shortcuts keep external data accessible in real time but require pipelines to integrate that data within broader workflows. Stored procedures ensure consistent transformations, yet rely on pipelines to trigger and parameterize their execution. Even Power BI templates, while providing a strong reporting framework, rely on clean, well-processed data from earlier stages. By combining these tools, Microsoft Fabric enables you to create hybrid workflows that adapt to your business needs without sacrificing reliability, efficiency, or scalability. Whether you're processing massive datasets, connecting to real-time external systems, or delivering actionable insights through standardized reporting, a layered toolset lets you balance the trade-offs inherent in any one solution. Each tool amplifies the capabilities of the others, producing a workflow that's not only streamlined but future-proof. So how do you effectively oversee such a multifaceted setup? To fully master this approach, you'll need to zero in on how data dependencies interact and evolve over time. Tracking these dependencies, ensuring proper sequencing, and maintaining operational stability across shifting business needs all depend on a holistic understanding of data lineage. That's what we'll cover next. How the Lineage View in Microsoft Fabric simplifies dependency management and gives you the confidence to implement changes without disrupting your workflows. Mastering the Lineage View, untangling dependencies. How do you ensure that a small change to one dataset doesn't break the rest of your workflow? It's one of the biggest risks when managing complex systems with interconnected data. In Microsoft Fabric, the answer lies in the Lineage View. a visual tool designed to help you untangle those dependencies and keep your workflows running smoothly. By offering a bird's-eye view of how your data flows and where it connects, the Lineage View makes it easier to spot potential issues before they escalate. At its core, the Lineage View gives you a map of your workspace, showing exactly how data moves between pipelines, notebooks, datasets, reports, and other Fabric components. When you open the view, it converts what would typically be a list of items into a dynamic, interconnected diagram. You can see the sources feeding into your workflows, the intermediate steps where data is processed, and the final outputs like dashboards or files. If you've ever wondered, where does this data actually come from? Or what happens if I modify this step? The Lineage View has the answers. Untracked dependencies are where things can get tricky. Let's say you're working with sales data in a centralized warehouse and decide to rename one of your key tables to reflect updated business terms. It seems like a small change until you realize that table feeds into 3 different datasets, which are then used by 2 separate pipelines and 3 Power BI reports. Without an organized way to track these connections, you might not notice until one of the reports starts throwing errors, leaving your team scrambling to find the broken link. Worse, if the issue is buried deep in an automated pipeline or relies on an external system, you might not figure it out until it causes delays or inaccuracies. Now, imagine the same scenario but with the Lineage View. Before renaming the table, you open Fabric's visual map and trace all the downstream dependencies. The Lineage View quickly highlights how every component links to that table, so you can instantly see which datasets, notebooks, and reports would be affected by the change. You might notice that 2 of the pipelines rely on this table for scheduled ingestion tasks. With this insight, you can either postpone the renaming until those pipelines are adjusted, or, even better, notify the teams using those pipelines ahead of time. This isn't theorizing, but a practical example of the benefits of dependency mapping. Proactive coordination saves a lot of potential problems downstream, especially as workflows grow more complex. The impact analysis tool within the Lineage View takes this functionality to the next level. By clicking on a specific item in the diagram, you can immediately see the scope of its reach. For example, selecting a particular dataset reveals all the notebooks, pipelines, and outputs like Power BI reports that depend on it. From there, you can notify relevant stakeholders directly. If the dataset is about to undergo maintenance or a schema change, you can send alerts to users managing the connected items, helping them prepare for any disruptions. As described in Fabric's documentation, impact analysis enables users to pinpoint downstream items that are influenced by changes to a particular Fabric item. By incorporating notification capabilities right into the platform, Microsoft Fabric streamlines the process of collaboration and change management. In fact, this proactive approach to stakeholder communication goes beyond reducing errors. It fosters better teamwork. When everyone knows how their components interact with the broader workflow, it's easier to make informed decisions and adapt processes to changing needs. For example, if your pipeline processing live transaction data is running slower and impacting dashboards, the Lineage View can pinpoint whether someone introduced a highly complex query upstream that is slowing things down. That insight can be shared with the responsible team, leading to quick fixes rather than back and forth blame games. Collaboration also becomes more seamless when the Lineage View is used to handle iterative changes. Take, for instance, a corporate scenario where departments each contribute their own datasets to a central reporting solution. Imagine finance updates a dataset with more detailed expense categories, while the HR dataset begins including new workforce KPIs. Both updates need to integrate with an existing pipeline, and at the same time, the dashboard team needs to ensure these changes reflect properly on their end. With the Lineage View, you can visually track how a single update cascades through the workflow, making adjustments in real time. Have the financing changes impacted performance? Is the HR dataset aligning with the schema expected by the Power BI reports? Rather than manual checks or trial and error fixes, the Lineage View lays out this entire flow, making debugging manageable. The ability to visualize workflows is critical, not just for day-to-day operations, but also for higher-level decision-making. For example, as data needs grow, you may need to optimize workflows to keep performance high. The Lineage View helps you identify which pipelines, datasets, or processes are under heavy strain. Perhaps you notice a shortcut that's queried more frequently than intended. leading to cross-region egress costs. Or maybe there's a notebook that takes significantly more time to run because it wasn't built with scalability in mind. Having this visibility allows you to optimize data flow paths, redistribute workload, or refine transformation logic to make your system leaner and more effective. Managing all of this hinges on clear data governance, and the Lineage View provides tools to keep you in control. Since it maps out every touch point between systems, you can ensure compliance and track how data flows, even across departments or external sources. Let's say you're dealing with customer transaction data containing personally identifiable information, PII. The Lineage View allows you to confirm that this data is only used in limited approved workflows. If it's feeding into a report or dataset outside of its intended scope, you'll catch the issue before it leads to compliance violations. However, as powerful as the Lineage View is, it's not a standalone solution. Dependency management extends beyond mapping connections. It requires adapting changes fluidly while maintaining workflow stability. For instance, changing table schemas or updating external source links often involves tweaking stored procedures that feed from those components. Stored procedures which allow you to centralize and secure transformation logic can be embedded into pipelines to act as safeguards. They ensure specific datasets remain formatted and consistent, avoiding problems even when other items upstream or downstream evolve. Let's take another example. Your organization wants to reuse a notebook that aggregates customer retention data into a unified table. Before finalizing this updated notebook, the Lineage View points out it feeds a pipeline running hourly ETL jobs, which in turn directly impacts a marketing report consumed by 5 different teams. By understanding this entire chain through the Lineage View, you can test the notebook changes in isolation without disrupting the automated updates. Once confirmed, stored procedures can streamline future transformations by embedding reusable business logic, ensuring no external changes cause unnecessary friction. Tracking and testing dependencies also rely on proper sequencing, and this ties directly into collaboration across teams. Using the Lineage View, data engineers can align with analysts and developers on critical handoff points. For example, say you plan to rebuild a pipeline connecting to a shortcut. The Lineage View allows you to check whether anyone else is actively querying that shortcut for other use cases. If so, reaching out to those teams proactively avoids unnecessary clashes or duplicate work. Additionally, when building workflows on such a multi-layered system, mistakes can happen, but catching and correcting them becomes much easier with Lineage. Suppose a user modifies a seniority column in an HR dataset, unaware that it's tied to compensation calculations downstream. The Lineage View lets you trace this change quickly, identifying everything impacted and notifying users before errors propagate further. Corrections can then be applied at the source or downstream as needed, keeping disruptions at a minimum. Finally, the Lineage View isn't just useful for understanding current setups, it helps lay the foundation for evolvable workflows. Because it clearly maps dependencies, you can confidently experiment with new components like adding real-time reports based on external shortcuts or integrating streaming analytics. Once those tests succeed, scaling them becomes straightforward without risking the stability of existing systems. So, what additional tools enhance this workflow clarity? Beyond stored procedures, pipelines play an important role in sequencing and orchestrating these dependencies. For example, with properly configured control flow logic in pipelines, you can ensure minor failures in one dataset don't cascade into widespread disruptions. You might configure dynamic execution where upstream delays adjust the pipeline schedule, minimizing downtime without requiring complete overhauls. In complex environments, the payoff becomes clear. Understanding where every link in the chain falls, using the Lineage View to anticipate challenges, and pairing that with effective transformation tools like stored procedures strengthens the integrity of your entire system. The goal is operational stability but also scalability, making it possible for your systems to grow without additional risks piling up. If your data workflows are the foundation of your decision-making process, maintaining their integrity isn't optional. With the Lineage View, you gain the clarity to make planned, impactful changes while minimizing disruption. And when paired with tools like stored procedures to lock in secure, reusable transformations, your workflows become not only dependable but also flexible enough to tackle new challenges. Speaking of stored procedures, they deserve their own focus, especially as a tool for handling transformations rooted in security and performance. In the next section, we'll explore why stored procedures are pivotal for managing reliable, scalable data workflows in Microsoft Fabric. Stored procedures, the hidden gem of Fabric. What if one tool could handle data transformations, enforce data security, and streamline orchestration all at once? Stored procedures in Microsoft Fabric deliver exactly that. While often labeled as complex or viewed as outdated, they are anything but. They're a critical feature for data warehouse management, offering a secure and modular way to perform transformations, manipulate data, and ensure efficient workflows. For data engineers managing complex systems, stored procedures aren't just helpful, they're essential. Let's start with the basics. A stored procedure is essentially a batch of SQL statements saved for reuse. But their power goes beyond simple SQL queries. What makes stored procedures stand out in Fabric's data tools is their flexibility. They allow you to centralize complex business logic, automate transformations, and secure access to sensitive data. For teams working at scale, stored procedures act as a single point of control, ensuring consistent and efficient data operations. But here's where misconceptions often surface. Some think of stored procedures as cumbersome or overly technical, a relic of older database systems. In reality, stored procedures in Fabric are designed to meet modern data engineering demands. For example, they work smoothly within pipelines, can take dynamic parameters, and support DML operations like inserting, deleting, or updating records. These abilities make them far more versatile than functions or views, which are often limited to specific use cases. Let's walk through a practical example. Imagine your organization maintains a sales data warehouse, and you need to apply regular updates to keep records accurate. Think of a scenario where incoming sales files contain both new transactions and changes to existing data, such as corrected amounts or updated customer information. Instead of running separate SQL scripts manually, you could create a stored procedure to automate this. The procedure might start by checking for duplicate records, updating existing rows, and finally inserting any new transactions. To make it dynamic, you can use input parameters like the date range for updates or the source file's location. For instance, here's how you might execute such a procedure. The stored procedure accepts a start date and end date parameter to process only the relevant data for that window of time. This means you can reuse the same procedure across different time periods or data sets, and by building in output parameters, the procedure can also return information like the number of rows successfully updated or flagged for errors. This feedback loop helps ensure transparency and allows engineers to monitor workflow performance. Stored procedures really start to shine when they're integrated into pipelines. Unlike running standalone SQL scripts, embedding a stored procedure within a pipeline lets you automate its execution as part of a broader data workflow. For example, your pipeline could pull raw data from a notebook or shortcut, run it through a stored procedure to clean and enrich it, and then export the results to a Power BI dataset for reporting. Because pipelines support retry logic and error handling, your stored procedure automatically benefits from these safeguards. Say the procedure encounters an issue such as a timeout or invalid parameter, pipelines allow you to configure retries or trigger alerts without manual intervention, keeping your workflows resilient. Now, let's talk about one of the most underrated strengths of stored procedures: their role in data security. In Fabric, stored procedures can act as a control layer, preventing users from accessing raw data directly. Instead of granting permissions to sensitive tables storing customer records or financial transactions, you can grant access only to the stored procedure itself. Users run the procedure to get pre-processed results, but never see the raw data behind the scenes. This is a critical feature for organizations working with regulated data, as it reduces the risk of accidental data exposure or unauthorized access. For example, imagine a stored procedure that calculates quarterly revenue based on thousands of sales transactions. Users can execute the procedure and receive aggregated totals, but they won't have access to individual line items. This level of control aligns with data governance practices, where enforcing granular access policies is just as important as ensuring data quality. Stored procedures are also modular by design. Complex workflows often require chaining together multiple steps, such as cleansing data, conducting enrichment, and calculating new metrics. Instead of packing all this logic into a single monolithic script, you can divide it into smaller reusable stored procedures. One procedure might validate incoming data, while another handles complex join operations to integrate two datasets. Once these individual procedures are set up, they can call one another as needed, forming a lightweight, maintainable structure. For instance, a pipeline calling a primary stored procedure could pass dynamic parameters, which trigger secondary procedures handling specific tasks. This modularity ensures your workflows scale easily without becoming unmanageable. When comparing stored procedures to other SQL-based tools like functions or views, the differences are distinct. Functions are excellent for reusable logic and calculations. Think of a function that computes year-over-year growth rates. However, functions are limited strictly to read operations. They can't perform the DML tasks, like inserting or updating records, that stored procedures excel at. Views, on the other hand, transform data at query time, storing the transformation logic but not its output. While they're useful for simplifying complex SQL joins or aggregations, they lack flexibility. For one, views don't support parameterized queries, which means every transformation must be hard-coded. They also require recalculations every time they're queried, which can inconvenience workflows with repeated or heavy usage. Stored procedures combine the advantages of dynamic logic and data manipulation. They give you the power to control not just how data is queried, but also how it's structured and updated within the warehouse. Take the insert, update, and delete operations as an example. They're not possible with views or functions, but are the bread and butter of stored procedures. This capability makes stored procedures indispensable for key ETL tasks like data loading, cleansing, or removing records no longer needed. Another strength of stored procedures is how well they enable automation. Within a pipeline, configuring a stored procedure activity is simple yet robust. You can specify which warehouse it targets, the procedure to run, and even import and define parameters all within the pipeline settings. For example, if the stored procedure expects region-specific data like region ID, the pipeline can trigger one execution per region by cycling through a predefined list of IDs. Coupled with retry settings and execution timeouts, pipelines ensure the stored procedure can handle real-world challenges such as transient connection failures or variable dataset sizes. Beyond automation and security, stored procedures also handle performance well. Since they run directly within the database engine, they're optimized for large-scale operations. Let's say you need to calculate rolling averages for millions of daily transactions. Offloading this kind of processing to a database engine via a stored procedure ensures faster execution times and puts less strain on upstream tools like notebooks or pipelines. By reducing the load earlier in the workflow, you also improve overall system efficiency. It's worth noting that stored procedures simplify downstream workflows by ensuring consistent data outputs. For example, when you pair stored procedures with Power BI, the data that enters your reports is already pre-aggregated, cleaned, and formatted. Analysts don't have to build additional transformation logic inside Power BI, saving time and reducing the risk of errors. In other words, the work done by a stored procedure earlier in the data process directly supports faster and more reliable reporting workflows. Let's revisit our earlier example, updating sales data through a pipeline. Consider what happens if the structure of the incoming sales file changes. Suddenly, certain fields might be missing while new ones are added. A well-designed stored procedure can include fallback logic for handling changes dynamically. For instance, it could ignore new columns or map renamed ones automatically, logging exceptions for review. This level of adaptability protects downstream processes from breaking whenever upstream changes occur. So, how do stored procedures compare to other tools for managing transformations? Think of them as the most complete option for scenarios requiring flexibility, security, and scalability. Functions and views have their advantages, especially for calculations or static logic, but they can't modify data or handle multiple dynamic parameters. Stored procedures, by design, are built for complexity, bringing together data transformations, orchestration, and access control in one package. Ultimately, stored procedures demonstrate the importance of leveraging the right tool for the right task. Whether you're automating regular updates, securing sensitive workflows, or optimizing resource usage, stored procedures bridge the gap between functionality and control. They ensure that your ETL workflows, when paired with pipelines, notebooks, or shortcuts, are robust, yet adaptable to evolution in source data or reporting needs. The choice to use a stored procedure isn't just about solving today's problems. It's about future-proofing your workflows. As business needs shift, stored procedures provide the foundation for scalable, modular, secure transformations, and they don't operate in isolation. When paired with pipelines to orchestrate execution or notebooks for advanced calculations, they become a powerful component of a broader data strategy. In the next section, we'll focus on how automation takes center stage. Scheduling your workflows effectively is the glue that ties all these tools together, ensuring that every task in your data pipeline runs like clockwork, even when you're not there to watch it. Scheduling, automating your data workflows. How do you ensure your ETL processes run like clockwork even when you're not around? Scheduling in Microsoft Fabric plays a crucial role in automating data workflows, ensuring all your data preparation tasks, from ingestion to transformation, happen exactly when they're supposed to. Whether you're working with pipelines, notebooks, or data flows, scheduling takes the burden off manual intervention, allowing you to focus on more value-added tasks while your workflows run smoothly in the background. Imagine a scenario where data from two different sources needs to be refreshed daily before the business day begins. One source comes from an external API requiring a notebook to handle complex transformations. The other consists of structured data ready to load through a data flow, requiring minimal processing before being loaded into Power BI. Without scheduling, you'd need to manually execute these tasks every morning, increasing the chances of delays or errors. But by automating refresh cycles, you guarantee that the data is ready and waiting for decision makers when they need it, no compromises. While scheduling simplifies life, it's not a one-size-fits-all solution. The options for scheduling within Fabric vary significantly depending on the tool you're working with, and each approach has trade-offs. Data flows, for example, offer a straightforward way to configure refresh frequencies. You can establish schedules on a daily, weekly, or even hourly basis, and this can take place entirely through simple workspace settings. But there is a catch. They're capped at 48 refreshes per day. This means the most frequent refresh you can configure for a data flow is every 30 minutes. For small-scale or non-real-time scenarios, this works perfectly, such as when syncing daily sales reports for teams who don't need minute-by-minute accuracy. However, in operations requiring high-frequency updates, this limitation might become a bottleneck. It forces you to balance refresh frequency against downstream demands to ensure data freshness without exceeding limits. Notebooks bring more granular control to scheduling, allowing you to configure executions down to the minute if needed. Simply open the schedule menu, define your intervals, hourly, daily, or custom, and set the start and end times. You can even assign a specific time zone, making it easier to align executions globally if your team works across multiple regions. This flexibility is perfect for use cases where timely transformations are critical. For example, if you're scheduling a notebook to extract and process real-time order data from an API, a refresh every 5 minutes might be ideal for keeping dashboards up to date. The downside, however, is resource consumption. Frequent notebook refreshes put strain on Fabric's capacity units. So balancing refresh frequency with cost efficiency becomes crucial. You'll want to carefully assess your business needs. Are real-time updates truly necessary? Or would hourly refreshes achieve the same outcome at a lower cost? Pipelines, on the other hand, offer the most robust and integrated scheduling options. Unlike data flows or notebooks, pipelines allow you to orchestrate multiple tools through a single timetable. Let's say you're building a workflow that first needs to execute a stored procedure for data validation, then refresh a notebook for advanced calculations, and finally load the results via a data flow into Power BI. Instead of manually managing the timing of each component, you can schedule the pipeline to execute all these steps in sequence. Need to make adjustments later? Pipelines let you modify schedules without disrupting the embedded tools, streamlining operations further. In practice, here's what this might look like. You set a pipeline to kick off at 3:00 a.m. daily, taking advantage of off-peak hours to minimize impact on system performance. The pipeline starts by executing the notebook, which pulls raw transaction data from an external source and validates key fields. Once the notebook completes, the pipeline transitions to the next activity, a stored procedure that performs calculations like aggregating sales metrics and categorizing customer transactions. Finally, the pipeline refreshes a data flow to load the processed data into a warehouse. All these steps run automatically, ensuring data is updated and ready for use as employees start their day. But as powerful as this orchestration is, pipelines aren't without limitations. For one, current scheduling in Fabric supports only time-based triggers, such as those set to run hourly or daily. There's no built-in functionality yet for event-based triggers, like kicking off a pipeline when a new file lands in Azure Blob Storage, or for advanced triggers like those based on HTTP requests or custom windows. For comparison, platforms like Azure Data Factory support these features, enabling more reactive workflows. In Fabric, this limitation means schedules must be thoughtfully configured ahead of time, relying on predictable timelines. Another advantage pipelines bring to scheduling is their ability to handle failures with grace. Imagine a notebook activity within a pipeline encounters a transient error. Maybe the Spark cluster is temporarily busy, or a network glitch impacts an external API call. Instead of failing outright, pipelines allow you to configure retry settings for notebook activities. By setting retries to 2 or 3 attempts, you give the task a better chance of completing successfully without requiring manual intervention. For instance, if a pipeline notebook fails to query an external API due to a rate limit error, retries ensure the notebook can try again when conditions improve. This built-in resilience increases the reliability of your workflows, ensuring transient issues don't disrupt daily operations. Failure notifications are another helpful feature. Pipelines enable you to configure alerts that immediately notify team members if something goes wrong. For example, if the final step in your pipeline, refreshing a Power BI dataset, fails to complete, an email or Teams notification can automatically alert the data team. This real-time visibility helps problems get addressed quickly, reducing downtime or delays to critical processes. Coupled with retry logic, these alert systems create a safety net, allowing you to trust that even complex workflows will run smoothly most of the time. The key to effective scheduling isn't just automation, it's optimizing your refresh schedules for performance and cost efficiency. Let's revisit the example of refreshing notebooks every 5 minutes. While this ensures real-time data for dashboards, it can quickly consume capacity units if overused. A more measured approach might involve breaking the task into 2 pipelines. One refreshes key metrics every 5 minutes for dashboards, while a second aggregates hourly data for less time-sensitive reports. By prioritizing tasks based on business needs, you maintain system efficiency without overspending. For data flows, the 48 refresh per day limit makes this optimization even more critical. For instance, if a data flow refreshes every 30 minutes, but downstream reports only load new data once an hour, you may be wasting half of your allotted refreshes. Configuring it to refresh hourly instead ensures alignment between upstream and downstream processes, eliminating redundant refresh cycles. Meanwhile, you can use pipeline orchestration to supplement these updates with more time-sensitive workflows, combining the best of both worlds. Troubleshooting failed executions is an important aspect of managing automated schedules. Pipelines provide a clear audit trail, so when something goes wrong, you can trace the issue back to its origin. For example, let's say a pipeline notebook fails during API data extraction. By reviewing the error logs directly within the pipeline interface, you might discover it was caused by an expired authentication token. Once resolved, you update the token credentials and rerun only the failed portion of the pipeline without resetting the entire workflow. This precision saves time and minimizes disruption. Finally, one of the biggest advantages of pipelines is their flexibility to combine different tools into a singular cohesive schedule. For instance, you might layer in a shortcut to connect directly to external storage like Amazon S3, ensuring real-time data access while your pipeline handles downstream refresh schedules. By combining this with stored procedures for transformations and notebooks for more detailed processing, your workflow becomes a finely tuned system capable of meeting business needs with minimal overhead. So, what's the takeaway? Among all scheduling options in Fabric, pipelines offer the most control and versatility for running complex workflows. Data flows are great for simpler use cases, especially when you need quick visual configuration. Notebooks excel when granular customization is required, but their value multiplies when incorporated into pipelines. Each tool plays a role, but when it comes to end-to-end automation, pipelines bring everything together, from handling dependencies to managing retries and alerts. As you've seen throughout this video, choosing the right tools and combining them smartly is key to successful data workflows in Microsoft Fabric. From the no-code simplicity of data flows to the advanced flexibility of notebooks, the orchestration power of pipelines, and the real-time access provided by shortcuts, each tool fills a unique role. Scheduling becomes the thread that ties it all together, ensuring your workflows run exactly when and how they're supposed to. In the next video, we'll put these concepts into action. We'll revisit real-world data challenges and demonstrate how Fabric's tools fit together to tackle them efficiently and effectively. Whether it's creating hybrid workflows or troubleshooting large-scale operations, you'll be equipped to handle the most complex scenarios with confidence. The final rescue, putting it all together. How do you save the day when the stakes are high and the clock is ticking? Let's revisit our opening challenge. You're tasked with extracting critical sales data from an external data source, validating it, transforming it, and preparing it for use in a Fabric data warehouse, all against a looming deadline. Picking the wrong tool or mismanaging the workflow could mean slow delivery or inaccurate data, which are risks too costly to accept. The solution lies in combining the strengths of Fabric's tools: notebooks for advanced transformations, pipelines for orchestration, shortcuts for real-time access, and stored procedures for secure and precise transformations. Let's break this task down into a hybrid solution to show you how these tools work together. You start with a notebook to extract data from an external REST API that updates daily with sales records. APIs often require handling specific challenges like authentication, pagination, and rate limits, which notebooks are well suited for because of their coding flexibility. First, Python is used in the notebook to authenticate the API connection, making secure requests for the sales data. The notebook then manages pagination, allowing it to retrieve hundreds of pages of records efficiently without missing a single transaction. Finally, it validates key fields like transaction dates and amounts, logging any inconsistencies or missing values for review while preparing the clean data for the next step. Once the clean data set is ready, a pipeline takes over, orchestrating its journey through the rest of the workflow. The pipeline not only ensures the notebook runs on schedule, but also monitors for potential execution failures. For example, if the API call fails due to a network glitch or an expired token, the pipeline's retry logic can automatically trigger another attempt. This ensures reliability without adding manual steps to the process. With the notebook complete and the data validated, the pipeline moves forward by leveraging a shortcut to integrate real-time data from an Azure Data Lake folder where transactional records update continuously. Shortcuts play a crucial role in this workflow by allowing the pipeline to access live data from the external data lake without moving or copying it into Fabric. This live link ensures that the transactional dataset is as current as possible, essential for accurate data reporting. However, managing shortcuts requires tight control over permissions to maintain both data security and integrity. To create the shortcut in your workspace, you need write permissions for the workspace itself and read permissions for the linked data source. If your pipeline involves modifying or writing new data back to the linked storage, you must also ensure write permissions exist at both ends. Without properly configured permissions, your shortcut could fail or lead to security vulnerabilities, so it's worth double-checking these settings during setup. Now that you've connected and validated the sales data from both the API and the live Azure Data Lake folder, you need to prepare it for ingestion into a centralized data warehouse. This is where stored procedures come into the picture. By embedding a stored procedure into the pipeline, you can perform transformations directly within the database environment. For instance, the stored procedure could merge the new batch of API data with the live transactional data accessed through the shortcut. Transformations might include handling duplicate records, calculating metrics like regional sales totals, or applying business logic to flag transactions that exceed predefined thresholds. What's powerful here is how stored procedures encapsulate all this complexity into reusable code. The pipeline simply feeds the data into the stored procedure with dynamic parameters like time ranges or region IDs, ensuring consistent processing regardless of the input. Let's add one more layer of real-world complexity. The stored procedure not only transforms the data but also feeds it into a summary table ready for reporting. This final table becomes the foundation of live dashboards accessed by the sales and marketing teams. Instead of loading raw, detailed data into Power BI, the stored procedure performs all the heavy lifting, cleansing, aggregating, and formatting before the data even reaches the report layer. This approach ensures fast and reliable dashboards while reducing resource consumption in downstream reporting systems. Scheduling ties this entire hybrid process together. The pipeline orchestrates when each component of the workflow runs and ensures that all dependencies align. For instance, the notebook extracting API data needs to run first, followed by the shortcut-linked data validation process, and finally, the execution of the stored procedure to load cleansed data into the warehouse. By setting the pipeline to trigger at an off-peak time, such as 3 o'clock, you can align these processes to minimize performance strain while ensuring data is ready for analysis before the working day begins. Robust scheduling options in pipelines also include failure alerts. So if any part of the workflow fails, whether it's a notebook execution or a stored procedure timeout, the system immediately notifies your team, enabling them to respond quickly. This workflow demonstrates how hybrid solutions leverage the best features of each Fabric tool. Notebooks handle complex extractions, pipelines provide reliable automation, shortcuts grant real-time data access, and stored procedures ensure secure, consistent data transformations. But success in real-world scenarios depends on more than just using these tools. It's about managing the connections and interactions between them effectively. For example, permissions management for shortcuts isn't just a technical step. It's central to ensuring data security. Imagine your shortcut accesses a folder containing sensitive sales records stored in Amazon S3. If permissions are too broad, such as granting write access to users who only need read access, you risk accidental overrides or exposure of confidential information. Similarly, if permissions are too restrictive, your pipeline might fail to execute entirely. Balancing these permissions is essential to maintaining both security and workflow stability. Scheduling also has its nuances. While pipelines provide flexible options, careful planning is necessary to avoid inefficiencies. For instance, if a notebook refreshes API data every 5 minutes, but the downstream stored procedure only runs once per hour, some of those notebook executions might be unnecessary. Aligning the schedule of each step in the workflow ensures balanced resource usage and reduces costs. This kind of optimization might seem small, but at scale, it can make a significant difference in both performance and budget. Another critical aspect of managing hybrid workflows is monitoring for errors and bottlenecks. Let's say the notebook task in your pipeline is frequently retrying due to API limits. Reviewing the pipeline's error logs might reveal that the API's rate limit is being exceeded because the notebook is using an inefficient pagination method. By resolving the coding issue within the notebook, you not only eliminate the retries, but also speed up the entire workflow. The same applies to stored procedures. If a transformation step in the stored procedure consistently hits performance bottlenecks, you might consider improving the database index strategy or breaking the procedure into smaller, modular parts. The practical takeaways from this workflow are clear. No single tool can handle every data challenge, but together they create workflows that are not only efficient but adaptable to future needs. And this adaptability is critical for real-world problem solving. Businesses grow, datasets expand, and reporting requirements evolve. By mastering how to combine notebooks, pipelines, shortcuts, and stored procedures, you're setting yourself up for success, no matter how complex your data challenges become. So, what's the ultimate insight from this rescue mission? It's that these tools don't operate in silos. They're designed to work together. Understanding their unique strengths and knowing how to combine them is what transforms a chaotic workflow into a seamless system capable of meeting tight deadlines without sacrificing accuracy or efficiency. The ability to troubleshoot permissions, optimize scheduling, and embed secure transformations isn't just a technical skill. It's a way of ensuring that your workflows stay agile, no matter what changes come your way. In the next video, we'll take everything we've explored in this series one step further. You've learned how to choose and combine tools, manage dependencies, and automate workflows, but how do you troubleshoot and refine those processes over time? We'll dive into advanced optimization techniques and ways to future-proof your workflows, ensuring you're always ready for whatever challenges come next in your DP600 journey. Mastering data ingestion tools is more than just a step toward passing the DP600 exam. It's a foundation for building effective, scalable workflows in your career. Each tool brings its own strength, but the magic happens when you experiment with combining them. Maybe a data flow pulls in raw data, a pipeline orchestrates scheduled tasks, and a notebook validates tricky edge cases, all seamlessly connected to deliver reliable results. Now it's your turn. Test these in your workflows, uncover what fits your needs, and refine along the way. In the next video, we'll focus on advanced strategies to elevate your skills even further.